So what if you could take a brilliant mathematical idea from the 1950s, right, and smash it together with today's most powerful AI? And what if that combination could solve some of science's toughest problems? Not just a little bit better, but way, way faster and more accurately. Well, that's exactly what we're diving into today.
Okay, let's get into it. Here's the plan. First, we'll talk about the invisible math that's kind of running our world behind the scenes. Then, we'll look at a really clever old school method for dealing with it. After that, we bring in the new powerhouse, the neural network. We'll see what happens when you combine the two. And finally, you're going to want to stick around for the results because they are stunning. All right, so first things first. To really get this, we have to understand the huge challenge that scientists and engineers face every single day.
I mean, think about it. You ever wonder how a video game makes a building crumble in that perfectly realistic way? Or how forecasters can possibly predict the weather days in advance? What is the magic behind all of that? Well, it's not magic, it's math. Specifically, a really powerful type of math called partial differential equations, or PDEs for short. These are basically the operating system for reality. They describe everything from how heat spreads through a room to how financial markets behave. They are, quite literally, everywhere. So here's the catch. Being able to solve these PDEs is absolutely critical for making progress in, well, almost everything. But the old school ways of doing it take a ton of computing power and a very long time. It's been a massive bottleneck for innovation for decades. So, faced with this roadblock, mathematicians got creative. They came up with a super elegant solution that's less about brute force calculation and more like a game of pinball. Way back in 1956, this idea called the walk-on-spheres method came along. It completely reframes the problem. Instead of trying to solve the whole complex equation at once, it just starts at one point and takes a random walk, step by step, until it hits the edge of whatever shape it's in. And you can see exactly how it works right here. You start at that point in the middle, find the biggest circle you can draw around it without going outside the lines, and then you randomly jump to somewhere on the edge of that circle. Then you just do it again and again and again. It's a series of random hops that eventually gets you an answer. It's clever, for sure, but you need a ton of these walks to get a result that's even close to accurate. Okay, now let's hit the fast forward button and jump to the modern era and introduce the technology that's been a game changer for, well, everything. The neural network. You know, neural networks are basically a form of AI that's kind of modeled after our own brains. And what they are amazing at is finding hidden patterns in huge amounts of data. This makes them the perfect new tool to throw at these really tough scientific problems, like solving PDEs. So this is where it gets really, really cool. What happens when you take that elegant, random walk from 1956 and you give it an AI-powered brain? Well, you get something that's not just better, it's transformative. This is exactly what a team of researchers did. They created a brand new method called WOS-NN. It doesn't just use a neural network alongside the old algorithm, it truly integrates them into one powerful hybrid system. And just look at the path on this slide. Remember the last one with all those big random hops? This looks totally different, right? It's not just jumping around anymore. The neural network is actually learning the shape of the solution as it goes, and it's guiding the walk intelligently. It's not just walking blind, it's learning with every step. The real aha moment for the researchers was figuring out that having two separate AIs working on the problem, like you see on the left, just wasn't efficient. The true breakthrough was creating a single integrated brain. That's the YZNN model on the right. This unified network learns not just what the answer might be, but also the best direction to go for the next step, all at the same time. It's like it's learning the map and planning its route simultaneously. Okay, so it's a really clever idea, but did it actually work? Was this smarter walk really any better? Well, let's look at the numbers because they are pretty wild. First up, accuracy. Compared to the classic method, the new WSNN approach reduced the average error by, get this, 75%. That's not just an improvement, that is a huge leap in getting the right answer. But here is the real kicker. It achieved that incredible accuracy while being unbelievably more efficient. It only needed 8% of the random walks that the original method required. I mean, think of the savings in computer time and energy. It's enormous. This graph says it all, doesn't it? That blue line is the classic method. Look at how many samples it takes just to get the error down.
Now, look at the green line, our new AI-powered method. It starts out with way less error and gets even better way faster. It's not even a fair fight. They are in completely different leagues.
And if you're a visual person, this is for you. On the left, that's the result from the old method. See how it's all noisy and jagged? It's just a rough guess. But on the right, that's the result from Wasson. It's smooth, it's clean, it's a nearly perfect match to the actual solution. The difference is literally night and day.
So why should you care about any of this? Well, this isn't just some abstract math trick. This breakthrough means we can have faster, more accurate physics simulations for science, much better graphics in our movies and games, and huge steps forward in everything from electrical engineering to designing new medicines.
The researchers summed it up perfectly. They said the secret sauce was that integrated training. By making the AI learn both the what, the answer, and the where to go next, the direction, all at once, it gained this much deeper, more precise understanding of the whole problem. And that's what's so incredible. This success story doesn't just close the book on one problem. It opens up this amazing, thrilling new question for all of science and tech. What other brilliant, time-tested ideas from the past are just sitting there waiting for an AI partner to unlock their true potential?